And then the, what's the shorthand notation for nickel?
Argon.
It's going to be argon.
3Da.
Wait, what comes first?
4s2.
4s2.
3Da. And then the 3Da.
Yes. 4s2. 3Da. Important here.
So anytime you're in the middle there, you got to start from the noble gases. You go, if you want to be the shorthand way.
Yeah, well, yeah, all of them you can start with the noble gas. We do that for, we did it for potassium. You just want to locate it on the periodic table so you know where that very last electron is going to go. It was 1, 2, 3, 4, 5, 6, 7, 8. That's the way to put it away. So you're filling in, and then you just backfill. Yeah, the shorthand is always starting from the noble gas plus the additional electrons. Because the noble gas represents the full quantum number shell. Right?
See that flash afterwards?
Right. Here's one for arsenic. Okay. You just start for hydrogen and just start filling. You're going, and then when you get to here, you can say argon.
Yeah, that's right, everybody. This is a very important slide to pay attention to. Thank you.
3D10, 4, 3, 1, 2. The periodic table is the best guide for filling this up. Just remember this way. N equals 1, 2, 3, 4, S, P, D. And be careful that the D is, remember it goes from 4S to 3D. Not 4S. Yes.
On my periodic table, it tells you the electron configuration, but it has AR3D, 8, and 4S2.
Yes. Some periodic tables will have these reversed. Say for we're going to talk about why in a minute. If you fill them appropriately, put that in as your phone. Either way is acceptable.
Scratch that. This is a fucking extremely important slide.
Yeah, we'll do some of these for starting on next Tuesday. Pop up with it, I'll have them ready there. Okay, so summarize this, right? Electrons occupy these orbitals to minimize the energy. Lower energy, N equals 1, 2, filled first. The outbound diagram tells us the order, and we can use the periodic table, 1s, 2s, 2p. These orbitals hold 2 electrons with the arrows pointing in opposite directions. That's called a spoon principle. And remember we showed the P's and the D's. You got to put 1 electron at a time. That's Hund's rule. Parallel. I'm going to do one more thing, introduce this, and then we'll stop here and come back, because this is a very important concept in the later chapter. Something called valence electrons. The electrons in all the subshells with the highest principal energy, that is the highest quantum power, are called valence electrons. Those are called valence electrons. Those are the ones that are involved in chemical bonding. Those are the ones that are involved in chemical bonding. Anything below those, N equals maximum, are the core electrons. Those are the core electrons. And it's been observed that some of the most important factors in the way atoms react is the number of valence electrons. So outer and highest quantum number electrons. The highest quantum number electrons. So here's our valence electrons. The highest quantum number for hydrogen was 1s. lithium 2s, sodium to 3s. And remember, the D's are never the valence electrons, because if you remember the D subshell, it's always one number lower. So that you indicated earlier that 1 through 8 in the main block elements identified how many valence electrons. We now know what that configuration is: 2s, 2p, 3s, 2p. Those are the valence electrons. Those are the electrons, the outermost shell. Those are the ones in chemical bonding. When the atoms gain and lose electrons, it's the valence electrons. Core electrons aren't involved in bonding. So if we look at selenium, here's a full electron configuration of selenium. Let's find that up here. Let's look at it. 34 electrons, right? Atomic number 34. It's first, second, third, fourth row down. So n equals 4 is the highest quantum number. Those are the valence electrons. N equals 4 is the highest quantum number here, right? Those are the valence electrons. These are core electrons. These are core electrons. So this has 6 valence electrons.
The other slide shows that, like, S3P is the valence electron.
Say again?
The previous one.
Just before this one?
Yeah. No, the one before that. Yeah, that's there.
Yeah. These are the valence electrons, right?
Yeah.
Selenium is the next row down, right?
Right.
Selenium is right under sulfur. So it's going to be 4s2, 4p4.
But also that 6A represents valence electrons.
Take note
Well,
of it.
total of 6 electrons.
And the
This
other,
tells you what shell and subshell they're in, right? This adds up to 6. That's all. Right?
Yeah.
6 total.
Yeah, but I don't get it.
Let's go back to this one.
Yeah, it wants me to.
You get these? You see this one?
Yeah, I don't understand how that's going to be on the electrons and then selenium as
Let's find where's selenium on the periodic table.
34. It's 34. And
What's right above it?
64. Sulfur. 16.
Yeah, so selenium is right here, right?
Yeah.
Se. Okay. So let's go from potassium. There's potassium,
So this is
calcium, and we're going to skip the D's because those are one quantum number lower, and we're going to go across to under aluminum, gallium, right? Germanium, arsenic. So if this is 2s, 2p4, 3s, 3p4, this has got to be 4s, 3p4, and so forth. See that? And p4s. That equals 1, 2, 3, 4. Got it?
do they all relate like that and going down?
Go down, they go.
Same row.
Wouldn't it be?
Oh, 4.
Yeah, 4 people. Yeah. Yeah, 2 people, 3 people.
4s, 2, 4 p4.
So if you find pretty much any one like that, then you can just using that to go down.
Yeah, because we're in that block that I had, it's a little handout. There.
Basically, if you do it, like, if you do argon is 4s, 3 people.
Yeah. Move this thing, right here.
So this one, using the current test, fill the shelf.
Here's your how to fill it right here. That's on Angel. Make yourself a copy of that, and you can see exactly how to fill the thing. Okay? Now you're back. Can't go wrong.
We have that.
No. But you have the periodic table.
Yeah.
Right? You can get any of these.
Hey, Moya.